All right, where we left off, I was talking about we had components and then we had the idea of unit vectors, and we wanted to go backwards. Right, we started with a length and a direction and got the components. Now we want to start with the components and get a length and a direction. And again, we're going to use the fact that we're dealing with right triangles. And right, we have a right triangle here. You should remember some of your, like if you were, it depends on what class you're in. I learned them when Miss Pugh taught them to me. And there's certain integer numbers that work for right triangles. One that you'll see a lot is 3, 4, 5. There's another one I use, it's 5, 12, and 13. And there's an infinite number of them. You can find them. There's ways of calculating them. But I just use those because they're convenient, because I can remember them. But the idea is that we know this side is 3 and this side is 4, and so the hypotenuse has to be 5 because of the Pythagorean theorem. And that's how we find the length of a vector. We use the Pythagorean theorem on the components. And that gets us 5, as we would expect. Right? And so this ax squared plus ay squared take square root, that's the length of A. That's what we mean by this A with bars around it. That is the length of the vector. And it looks like absolute value, and that's why. It's coming from that sort of thing. The absolute value says ignore the sign. Here it means ignore the direction. If this is the positive direction for the vector, negative is the other way. But we don't care, we just want the length of it. So that's how we find the length. Now, we find a direction we find a direction. We find this angle theta by saying, well, we know the opposite side and we know the adjacent side, and opposite over adjacent is tangent of theta. The tangent of theta here is the y component divided by the x component, which in this case is 4 divided by 3 is 1 1/3, and that gives you 53 degrees. All right, we have to apply inverse tangent to both sides. And if you'll give me a second here, I do want to point out I'm not 100% prepared, but here we are. Let's see if I can get to something else. Here comes the webcam. Here is my calculator. Now, I wanted to talk about this because I want to focus it. There we go. So I'm seeing this kind of mirror image. You need to know how you use your calculator. All right, I have a few different ones that sometimes I use my cell phone, right? And I use it as a calculator. You guys almost certainly have TI-83s, TI-84s. A few people had 85s and 6s, and that was weird. But you need to know where the commands are on your calculator. And if you're doing trig, right, sine, cosine, tangent, and then the inverse is shift. Inverse sine is the thing that is, let me move it to the side here. And mine is in yellow, and of course that blends in the light. So sine, cosine, tangent. All right. So we have these functions, and you need to know how to use your calculator. And I'll point out something while I'm here as an aside. I know I'm going off on tangents, but my calculator, and yours probably does too, has functions here that is going rectangular to polar and polar to rectangular. All right, so what we'll do is we'll zoom out a bit and focus. But the gist of it is, if I have vectors, so I have the number 3, and I want to add 3 and 4 and get 5. All right, I want to do the Pythagorean theorem. Well, I'm going to convert rectangular to polar, and I want to insert 4 And what it gives me is the rectangular part is, sorry, the polar radius is 5. And I can get the angle out of it is 53.1. Your calculator probably can do that. And if you know the functions on your calculator and work with it enough, you can do these simplifications. You can do things like use the memory and work the parentheses and stuff, and you can use these other functions. Now, if you don't, that's fine. You can absolutely do, all right, 4 divided by 3 and take the inverse tangent and you get 53.1. Or you can do 3 squared plus 4 squared equals 25 squared 5. Right? So there are multiple ways of solving problems sometimes, but the important thing is that you're familiar with your tools and that you bring batteries to a test. We have a test and your calculator doesn't work, you're going to get one out of the box, which probably will be kind of similar to mine, which means it's not a TI-83. So we're going to go back to the documents that we had here. Right. We're trying to find length and direction, and we're going to eventually start talking about solving problems. And so here is a problem we want to solve. And now that we've done that, I want to go back to the webcam because I want to write this out. I want to show you how to write out a problem like this. So on one side, we have, the writing we're going to do, and on the other side we have the problem. And eventually I'll adjust this so we just have the stuff. But what we've got is 2 vectors, A and B, and we want to add them. And knowing we want to add them, I'm just going to draw them directly out. And so A is going to go up like that. That's our A. And it is 4.1 meters. And this angle here, theta sub A, is going to be 35 degrees. We're giving these things some labels. So length of A is there. And then I'm going to draw B as if I'm graphically doing it, because I can do that if it's simple enough. Come on. All right, there's B. Let me move it down. And B's length is 5.3 meters, and theta B is 112 degrees. And what that means is we have an x-axis here, right? We have, I'm trying to do it off to the side here. I realize I need to zoom out a bit. Out. I need to zoom out. There we go. All right. So we have an x-axis and a y-axis, and we measure from the positive x-axis counterclockwise. So if we put in axes here, this is 112 degrees, and this is 35 degrees. Right. So when you're setting problems up, I recommend you always do things from the positive x-axis and get numbers like this. It's not always possible. Sometimes you end up with, you have some drawing somewhere where everything is talking about doing map directions, or you've got a drawing where it kind of just makes sense to find this other angle over here, which is 180 minus 112. Could be 68. Yeah, 68 degrees. And so it makes sense to try to get numbers smaller than 90 degrees, but it loses information. And the reason is we can come over here and we can do 112 and take the cosine of it, and you get a negative number. But if we do 68 and do the cosine, that's a positive number. And the reason for that is this whole thing that you should have picked up in your calculus, or sorry, in your trig of quadrants, right? Here, everything's positive. Here, everything's negative. Here, you got a positive and a negative, and positive sine, negative cosine. Here you have positive cosine and negative sine. Right. If you remember your quadrants, you have that information stored in the angle. But if you convert it to something less than 90 degrees, you lose it. And then you have to go and think, well, this thing's going up and to the left. That's second quadrant. That's negative cosine, positive sine. So I recommend always going from the angle that gives you the indication of where it goes. But anyway, we have these things. We can find the components, and that's the goal, is to add these components. And if I draw it over here, what it will look like is we're going to add a sub x, and then we're going to immediately add b sub x, like that. And then we're going to draw a sub y and b sub y. So we want to find those components. That's what we're trying to do. And so we go and we say, well, what are the components of A? Well, the components of A in the y direction, the components A in the y direction is length of A sine theta, which is 4.1 meters sine of 35 degrees. And that's some number. In the slides, we'll come back to in a second. And a sub x is length of A cosine of theta, which is 4.1 meters sine of 35 degrees. And we do the same thing for B. Right? B sub x is B sine theta, B sub y, cosine. And B sub y is B sine theta. And we do the same sorts of things. And we'll note that when we do this, B sub y will be positive because the vector is going upwards. B sub x will be negative because the vector is going leftwards, going in negative x direction. So that is a lot of drawing on the webcam. I'm not sure it comes through as well. But what I'm going to do is go back to the document because it's all here in the documents. Now we will practice this some more, and I'll do this better. We'll do videos that are higher quality as we need, but we'll practice more of this. But for this, we want to find the components. We want to find those values, ax, ay, bx, by. And there they are. All right, there's our initial information. There's the components. That's what we expect. All right, ax and ay are positive because it's going in the positive direction here, like this, positive x, positive y. And b is 1 negative, 1 positive because it's going this way. Sorry, when I said this way, that I'm not doing good with the computer right now. I probably need to stop for the day. It's going like that. So we find the components, and I make this note here in the notes that the correct angle will give you all the information. We will practice some where you don't have that, where you got to do like map directions. But you know, you want to always try to measure from the positive x-axis. And so we take those components and we add them, right? So our sum is going to be C. Well, the x part of C is just ax plus bx. We add those. And we're adding a positive number and a negative number, so we get something a little smaller. That works. And C sub y is a sub y plus b sub y. We check those. And that works out okay. This is our vector C, but it's not the way it's stated. In the question, we're asked for magnitude and direction. We're not done. We got to do the vector C here in terms of magnitude and direction. And that is just what we did before with the Pythagorean theorem and tangent theta. Right? We have the vector C, the length of it, we apply the Pythagorean theorem and we get a vector. And then we apply tangent theta is the y over x. And so theta is the inverse tangent, and that's about 79 degrees. And so that's the process in which we do these problems. We go, all right, let me type up where we do our process is, the first thing we do is draw a picture. And then the second thing we do, and this is where I'm going to stretch this out. The second thing we do is find components. And then the third thing we do is add them. And then the fourth thing we do is find magnitude and direction. That's what we do. So we don't have to do all of them all of the time. All right, if I give you a problem in the homework, I wonder if I have the homework available. Not right now. So I have a problem in the homework that just gives you vectors in this form, in the I and j hat directions, or in the x and y parts. I just give you the components directly. You don't have to draw the picture for that necessarily. You have the components, you don't have to do that. You just do the addition, and then if it asks for it, you do the magnitude and direction. Sometimes this is all I want, or sometimes the homework, that's all you need for the problem. But a lot of the times you need to have some intuition, like if we're adding forces up, we want to find the total force. Well, we need to know this magnitude. It doesn't help us just to know the components, because that's the two things that we were adding. So we want to find the magnitude and the direction. So we don't always start at number one, but we always go in this order, and we go until we have the solution. So just to show you, the remaining slides here is graphically illustrating what we did in this problem. All right, we have, let me turn off annotations. All right, we have A and B. We have the two vectors in black. And then in red, I have the components of AX and AY, and we're adding them. And when I do these in these graphs, I'm doing them to scale. This actually is 3.36 units, and this is 2.35 units. And we're going to add AX and AY and BX and BY. And graphically, we add A by starting at the beginning of A, the tail of the vector, and we go to the head. In this case, we're going through the components, so we go X first, then Y. And then we have B right beside it, head to tail, and we go from the tail of B to the head of B. And that gives us, our result is some vector that goes up like that, from the origin up to the tip of B. And there it is. And this is the path that we took without dealing with the shape, this odd triangle that we had back here. These two sides, this is not a right angle, but we just have this, and it's a result of these four additions. But we can do those additions in any order. So we can swap A and B around. Instead of this, we can add AX and BX first, and that gets us to this point in the middle. And then we add AY and BY. And that's what we're doing when we add the components. We're adding the X stuff first, and then we're adding the Y stuff. And those two parts, this little component right here is C sub X. From here to there is C sub X. And then this long bit is C sub Y. Those are the components that we go and we find the magnitude and the direction. All right. So I think that is all of the slides that I have. When we do the next video, I'm going to send you these 3 videos today as links. And then tomorrow and Thursday, and from then on, if you have questions and they merit a video, I'll do that. If we have supplemental videos Like I want to go over the estimation and the order of magnitude stuff because I think it's interesting, but that's supplemental. And then if we do problem solving, the videos you want to see are probably these where I'm walking through the lecture like this and where I'm solving the problems. Those are the things that are going to be important to you. The other things, when I take 5 minutes to talk about my calculator and how you should work with your tools, that is good to know, but it's supplementary. When I talk about order of magnitude, I'm going to talk about logarithms, and that's good to know. It's worth it to know it. You should listen to it. But if you miss it, you're still going to have the things I want you to know from vectors. All right, so understand that you're going to get a link to the important stuff, and then you're going to get a link to other stuff as I have time to make it. So that is a lot of this class is time management. You're going to be under as much stress as I'm going to be under trying to fit everything in the time that we have. It's 2:30 now in the afternoon, and I've got to go to Radford and do paperwork before they leave. So hopefully I get there. But yeah, I will send you the links to these. I do want your feedback if there's something you don't understand or if you think that there's a better way for me to try to show this. I want that feedback. I'll listen to it. And if you have any questions, please email me. We did the office hours today. I had one person stay and talk for a while. If there's some understanding how to do that, I can go through some information for that as well. I'll email about that. But yeah, we're going to try to get through this stuff, and you're going to need to be flexible, and you're going to also have to manage your time because I know you've got 5 other classes here. All right, you got science fair, and you've got this class, and your elective, and your math. At least 4. So, and then you got to go to do your home high school. I don't know what that entails. So, anyway, I hope you all have a good day. Please email me if you have questions.